Welcome back, chemists. We have discussed chemical properties, and I'm just going to do a quick, we just spoke about these, I should have been writing them. Some common chemical properties that we saw was flammability, acidity, and then this last one I don't think we wrote down, we just did the H2O2 example, right? What's H2O2? Hydrogen peroxide. Now, I would classify that property as reactivity. The fact that it just reacts with sunlight is pretty cool. Does your skin react with sunlight? Very technically, yeah, absolutely. You get tan, right? It changes the pigment and the hue of the pigments in one's skin. Is there anything other than aesthetic reasons, which do you guys know what aesthetics mean? Yeah. What? Like it looks good. Yeah, is there any other reason than just people like to look bronze or tan for whatever, regardless of the reasoning, is there anything other than like look and
Sun D or something?
Ooh.
Vitamin D.
Sunny D? You guys ever drunk it? Drink it?
Yeah.
I think it works. I just think it's too old-timey. Okay, Sunny D. Why is it called Sunny D?
Because it's sunny and it gives vitamin D.
It's vitamin D, which normally, where do people get vitamin D?
The sun.
The sun. It's a chemical reaction in your body. You need UV light. You have to have it. There are places in Siberia where the pictures look so creepy because part of kindergarten in Siberia, which is northern Russia. Lando, this is crazy. I'm not going to show you the guys the pictures. But there's like in kindergarten in northern Russia and Siberia, and probably in Sweden and Scandinavian countries as well. In kindergarten and elementary school, the kids will come with bathing suits. Now they're in like the cold, right? They're in the Arctic. They come with bathing suits. They don't go swimming, not up there unless they have a heated pool. But what they do is they have all these kids get in their bathing suits during the winter time, and they all bathe in the sunlight lamp, a UV lamp in the middle of the room. So you have a bunch of kids in bathing suits who have to go stand in front of UV light because if they don't, their body lacks which essential vitamin? Vitamin
Why do
D.
they have to wear swimsuits?
Because if you're wearing your parka, how much vitamin D is your skin?
I'm
Yeah,
sure,
yeah. Yep, for sure. You get scurvy. Yeah. All right. So here we go. Moving forward, though, one of the things, these are all chemical properties that we will be able to get like exposure to and we will see and work with in the lab. As we go, though, we're going to transition a little bit today because beyond that, you can't always see them perfectly clear and it's not always like really obvious. Our next main focus is going to be, same section still, but how does one actually go about detecting chemical changes? Now, we can make a decision as a class real quick. We can keep calling them chemical changes. I have no issue with that. Alternatively, though, if you are going to change the fundamental structure of some substance, you're going to move atoms around through something. You can either call that a chemical change or a chemical reaction. Which would you prefer we go with?
Reaction.
Okay, I will write the word. Can somebody recall what is the shorthand for reaction? RXN. Okay, detecting chemical reactions then. Now, when we look at these, some of them are visible with the naked eye. You can just see them happen. There are a bunch that exist, however, that you can't see. The H2O2 example is a good one. Have you guys ever seen what hydrogen peroxide looks like out of the bottle?
No.
Looks like water.
Oh, yeah.
When it reacts with UV light and decomposes into water and a clear gas, what's it still going to look like? Still just going to look the same, right? It's going to look exactly the same. Sorry?
How do you even know what that is?
What?
Hydrogen peroxide.
How do I personally know what it is?
No, yeah. Everybody else knows it. I don't know what it is.
I've mentioned it a bunch of times. Hydrogen peroxide, have you ever had a cut in your hand and somebody pours stuff that makes a bubble?
You ever put it in your ear before? Not bubble. You ever had like
I'll show you.
brown
It's,
bottle you pour it in your ear? When you have an earache?
I've never done that.
I've done it.
Yeah. I give it to my dogs if they eat chocolate because
The-
it makes them vomit.
Oh, yeah.
Yeah.
Is it the thing you put like in those cottons and then put
I
it
do it all.
and it's like reddish?
So that's iodine. I'll show you. I'll show you a bottle. Maybe it's probably more common if you've done things like that. Maybe it's more common down south, like in the Midwest. Yeah, me too. Like I grew up, we had it around everywhere. But your mom grew up down south in the Midwest or the Mountain West. Okay, anyway, as we're looking at these, here we go. When we look at chemical reactions and detecting them, all we really look for are some changes. All right, guys, let's focus in here. Changes we observe. It's the Midwest. It's porn language, but talk with geography about that. All right, here we go. Let's check it out, guys. Back together. We're going to kill the Midwest conversation for a second. Changes that are common that we can see. There are a few of them. For example, if you have a rock of sulfur in front of you, you probably don't smell it. Not noticeably anyway. If you scratch a little bit, I think we did that earlier this year, you can smell it a little, the yellow one. Okay, however, if you think of volcanoes going off, and some of you have probably noticed this, have you ever walked outside and thought, man, it sure stinks outside today?
Yeah.
Okay, especially when volcanoes go off, why? The gases. Those gases are released and they react in that process, right? So, common things that you might see. Odor change or odor production.
Has Miss Peter's face always been there? Is that Peter's? Whose face is that? That almost looks like Peter. Is that your face?
Wait, it was there before.
Wait,
What the hell is
do you guys see what I mean though? It almost looks like Peter. It does look like Miss Peter.
So it's weird, but check this out. Every human, okay, that's not true. Most humans have hair and eyes. So I think that if we hide this part, it's probably kind of hard to tell who I am. Well, obviously, yeah. All right. Okay, anyway, odor production, really common. There's easier places than just thinking about volcanoes go off. If you drink milk, how do you tell if it's bad?
It smells weird.
It starts to smell bad, right? If it's really bad, it'll be solid, but even before it turns solid and chunky, it smells. Like it starts to stink. Food rots, yeah? Everybody agree with that statement?
Yeah.
Food rots, and when it rots, it's a chemical reaction that's going on. Does rotting food stink?
Yes.
Did it stink before it rotted? We changed or produced a new odor in that process. Chemical reaction, indicative, odor change. Okay, another one. Here we go. If you strike a match, does it make light?
Yes.
It makes light in the form of fire, but it makes light, right? So check that out. I would make the claim that that is just energy released. Okay, when you have an energy release, there are two different ways primarily that you're going to encounter them. The first one, and I'm just going to do these underneath, light. Light is an easy way for energy to be released from something. Neon signs are just energy releasing from the neon inside of it as electricity passes through. There is another way that this can happen. Anybody ever seen one of those things that you put in your pockets when you go skiing or hiking or whatever in the wintertime, that you squeeze it and all of a sudden your hand's warm?
Hand pocket?
Like a hand warmer? Yeah, absolutely. Energy can be released via a chemical reaction in the form of light. It can be released in a chemical reaction in the form of heat. Or thermal energy, if you would rather. Okay, beyond that, we're going to get some fancy words. You guys have likely never seen this word. Effer, E-F-F-E-R, vescence. V-E-S-C-E-N-S-C-E. Okay, you've probably all, maybe you've seen it, depending, I don't know. I've never had heartburn in my life, not a single time.
What?
No.
Never. I think I had it once and I thought I was having a heart attack and it freaked me out. Nope, I've never had heartburn. I can eat the spiciest of the spicy, the sourest of the sour, nothing. Like nothing. Okay, now, here's the deal though. I, right next to my desk, have this. How many of you guys have seen these things?
What is it?
This is an antacid tablet.
Wait, I literally have your backpack in my backpack.
Yeah, so check it out. We probably have different kinds. Tums is a common brand.
Very
Okay, I bought something a little different than Tums. Will you read this to me? These are antacid tablets. What sort of antacid tablets?
Aspirin.
Nope, before that. Very top. Give me that first adjective. Before you see acid and pain relief. You missed a V, I think. Is it effervescent?
Effervescent. Oh
What
my
on earth? This shows up on the regular shelf that you look at. These are effervescent tablets. Have you guys ever seen these? Okay,
I've seen
so
Tums.
you've seen Tums. I'm going to steal this. We will play around with this idea next in the lab, but I do want to show you just a little bit of effervescence. So give me like 30 seconds.
Doesn't it dissolve in the water?
So it's cooler than that. Don't cause a ruckus. I'll be right back.
Don't cause me
Really?
No. Take no.
I lost that pencil. I lost that pencil.
No.
It's okay, y'all can keep it though. But
Okay.
Back off.
Yeah, I told you. We're back. So,
Says you're like a child.
checkity check this out. Okay. As we go through, pretty cool, huh? As we go through, let me switch this so that they can see me as well.
also, when you say stuff like checkity checks. Like it kind of reminds me of that one dude from The Simpsons.
Makes me think of beatboxing contests.
Like
I don't know. Anyway, or like performing. Okay, check this out. I have water. I'm not trying to be tricky. I have water. What state of matter is this?
Liquid.
You think there's some gases dissolved in here?
Yeah.
Yep, there better be. Otherwise, you have really odd water. Okay, so I have a liquid there, right? Okay, this is an antacid tablet, an effervescent antacid tablet. Beautiful. Okay, if you want to know, we'll talk about the chemical composition. I believe it's calcium bicarbonate is what these typically are. But this is a liquid as well? No, okay, it's a gas then, right? Oh my gosh, it's a solid. Okay, effervescence is a really fancy word for what you're about to see happen. Okay, the effervescent quality of this. You guys obviously know that sometimes things dissolve in water. Okay, now I have a solid and a liquid, right? Check it out. Here's an antacid dripping in.
It's like that stuff you take when you're sick.
Okay, yeah. Oh, yeah, this is absolutely something you take when you're sick. Alka-Seltzer is the name brand of sodium bicarbonate tablets. Okay, as you're going here, what you are seeing right here is effervescence. That's what it is. That's the fancy formal science word for it. Give me the regular language word for what effervescence is. Fizzing. It's the fizziness. Okay, we'll let that set for a second. It does look like Sprite. Sprite is also effervescent, but for a different reason. We're just going to say effervescence is gas production. So like there was a gas that's coming off of that, right? That's why the bubbles are there. Or in more common language, fizzing.
I'm not moving my foot.
Okay, effervescence is the idea of producing a new gas or fizzing. Now check it out. I'll go back to the camera. This has been like 30 seconds. It's done. Like it's gone. It's not even in here anymore. Now what you will notice though is some of that solid white calcium bicarbonate wound up in a gas form and kind of popped out the top. I have a white residue that's formed around the outside of this and bubbles everywhere because they stick to the side. Okay, that is effervescence. We will play around with that idea and specifically with those tablets next week as well. Okay, beyond those, there are some other ones that are really common. You can obviously see effervescence. You will notice a distinct change in odor in situations. Gas production. You will notice a light release or a heat release if you're holding something and it's reacting. Another one that's really easy to see, I don't have a quick demo for this one, is a solid precipitate. Okay, we have used this word. I don't know if we've written it down. When you see precipitation, like rain and stuff, is when stuff falls from the sky, right? Now, I haven't done this yet. I will make sure we have a demo of it. But there are things that you mix two liquids together and all of a sudden you get solid stuff at the bottom. Like it happens. That is a precipitate. The last one that is pretty easy to see, depending, is a change in color. And I'm going to make sure that we just clear something up because there's one weird situation. Change in color. Give me a chemical reaction, and you don't even have to be the chemicals and stuff. Something that you guys do every day. I think I mentioned it yesterday, that you use to change color of something. Food dye could be, possibly. Tie-dyeing, definitely. Another easy one, if you stain your shirt, what do you put on it? Bleach, and then it pulls that color out, right? There's a noticeable change in color. That is a color change that we're after. The weird piece, one second, Trace. The weird piece that I need to make sure that we're all on board with is we mentioned yesterday that what happens with metal when you heat it? It glows and the color changes. Temporarily, though, right? That temporary color change is a change in the temperature and how we interpret it. It's not a chemical reaction. Temp change is a physical change. Trace, you had a question.
So wouldn't like milk and chocolate syrup do the same thing too? Like,
So, kind of. The mixture changes color briefly, right? We're looking for that permanent aspect of it. You've never done it because you've never had a reason to. But if you have, like, it's easier to talk about with water. Muddy water's brown, right?
yeah.
Like if I have clean water and I pour mud in it and I stir it up, it's going to be brown water. You might think that that's a change in color. And it is, right? However, how long will that last? Do I just let that water set for several days?
It's probably gonna go
It's going to sink down to the bottom, right? And we're going to have, like, they're going to re-separate themselves. That's going back to that idea of mixtures. The color change that we're after is a permanent color change. Okay. These are the easiest ways that one can notice and very clearly identify that a chemical reaction has happened. There's some really cool ones here. Changes in color are sometimes associated with light. You ever seen one of those really cool things go, and now it glows?
Glow stick. Yeah.
Chemical reaction. You get two of them at the same time. You produce light and you produce a change in color, which is pretty cool. Okay, as we go through here, it turns out that using these changes and taking advantage of these changes honestly doesn't happen a whole lot in your regular everyday lives, right? You probably don't use bleach every single day, is my guess. Where this does happen and these chemical changes really occur are two places. They happen industrially. If you wanted to buy gold, like let's say you had a bunch of money, you want a new sick chain. Hold on, a new drippy chain. There we go. Right? You think people you've seen people paying for gold, I imagine,
Oh,
or how they get it, right?
I grew up around that.
Okay, yeah, so in most of Alaska, especially along the western coast of Alaska, there's gold. There's a reason that people are here. There's gold in them there hills. As we look at it then, people can get gold out of riverbeds, right? Now, is that where most of the gold on our planet comes from? No, a lot of it comes from dredging. In this state, I would imagine most of it probably comes from dredging, is my guess, or panning in some variation. But a lot of the time, you literally just dig up rock, you crush rock, you chemically react the rock, and now you have a purified form of that, right? Like, there's oxygen in this window, but it's not usable as oxygen. There's a lot of oxygen in this. There's a lot of silicon in this. I can't get either of them right now until we chemically react somehow to separate them. Most of it happens from humans in industry, but there's another huge place where this happens. Who has seen the Grand Canyon?
I've seen a mini.
Who's seen a picture of the Grand Canyon?
I've seen the mini version. They're like a mini Grand
What's the mini Grand Canyon?
It's kind of the Grand Canyon with mini.
The nearly
Oh my
grand.
God.
It's in like.
All right. Okay. So check this out though. Where these really happen, turns out our world loves chemical reactions. And by our world, I mean Terra, our Earth, like specifically the celestial body, that big rock spaceship that we're all flying on right now. Okay. For real, it's just a big rock flying through space. We're on a spaceship. We just can't control where it goes. Okay. As we're looking at that, the biggest place that you will regularly see evidence of chemical reactions is through a geologic kind of view where we look at weathering. Lots of fancy language showing up today, I imagine. Really important when I say something that you don't know what it means, you do what? What's geologic? Geology, rocks. Yeah, absolutely. Okay, as we're looking at this, specifically, let's just think about how these changes happen. There's a lot of changes that happen with weathering. There are some that are physical. The Grand Canyon is gigantic, right? Yeah. It's huge, it's grand, one could say. The true meaning of the word awesome, realistically, because awe is like, whoa, like that's what awesome is supposed to mean. We use it way too much. I use it way too much. Okay, how did the Grand Canyon form?
Bunch of water.
Erosion.
Yeah.
Oh my goodness. Now, as you look at erosion, there's a few different things going on, and we can focus on the physical change right now. What's erosion?
Water passes through over something like a pond.
So if we have a tiny stream running through rock, and we're going to let that tiny stream run for the next 100,000 years,
The rocks gonna
It
split.
like so.
it's going to slowly start carrying away a bit of that rock with it, right? Just through the friction with the water itself, along with friction of the stuff that's traveling through that water. Erosion is a good example of a physical change in physical weathering that you're going to see. Kennedy, go ahead.
So in Chattanooga, Tennessee, there's this place called Rock City, and it's like this. It's all about like mostly geology, rocks.
Yeah.
Obviously it's called Rock City, and they have these giant rocks, and there's little stands that say like 5 years, 10 years, 15 years, and it's like how long that water has been streaming through that rock, and some are like super deep, and some are just started.
Cool.
And they have like erosion experiments. All
Oh,
through the
it's,
park.
yeah, it's super neat stuff.
You can tell whether how old they are, how they are. One's like, I don't know, like 50 or something.
Oh, no, it's super cool stuff. It's just hard to be able to see it. Like, that's awesome that they have it set up for this much time so you can actually see it. Okay, erosion produces sediment. Have you guys ever seen the word sediment?
Yeah. Start from
Okay, sediment are just really, really, really tiny small particles of rock. So you talk about sedimentary rock, if you remember talking about Earth and space science. Sedimentary, igneous, and metamorphic are the three big ones that you guys, I'm sure, spoke about at least some. Erosion produces sediment. Now, other big physical changes. Have you guys ever seen a large boulder? Is it likely that you have? Guarantee you have. I thought you said no. I'm sorry. Do you think it came from a larger boulder?
Yeah.
If human beings didn't split it, how did it split?
If so,
So it could be erosion, but that would make typically like a nice smooth earthquake could happen. Does it rain here? Are all rocks completely watertight all the time?
Oh, is it if the rain goes in and it freezes and then it breaks?
Oh my gosh.
Yeah.
Rain or water seeping in, which is just slowly getting into it, right? Water seeping in and freezing. What does freezing water do?
Expand. Yeah.
Yeah, water seeping in and freezing can break, and I'm going to go out bigger than Boulder here. We're going to say can break mountains. Because really, what is a mountain other than a gigantic boulder?
It is literally
It's-
a giant boulder.
Yeah, it's just a big piece of earth.
Didn't
Now,
it used to be like a volcano or something?
lots of stuff used to be volcano or something. Okay, as we go in here, these physical changes are all over the place, especially in geology. Okay, they can be human-made or natural, more natural than human-made in all reality. Okay, beyond that, there are a lot of chemical reactions that happen in this weathering process as well. So remember, we're going to use chemical reaction instead of change, but are they different? Reaction and change, when we're talking in terms of chemistry, we're going to think of it as being the same thing. They're not interchangeable in every situation, but a chemical reaction and a chemical change, same. Okay, there are harder to see examples of this, but as we go here, we're going to look at a couple different cool things. You guys ever heard the song The Cliffs of Dover? All right, so two things going on right now. You hear Eric Johnson playing Cliffs of Dover with one of the coolest guitar licks ever.
I seen him like.
Okay, and beyond that, this song, I don't know why it's named Cliffs of Dover, but what we're looking at here are literally the Cliffs of Dover. Okay, this is in England, I think, England or Ireland. We'll just say the UK so we can make sure we hit all of them. Okay, the Cliffs of Dover. Do they look like every other cliff that you've ever seen?
Yes.
Do they? Look at the, let's see.
Cut straight down.
Gosh, there's a few different things. What color is rock typically?
It's like the worst. It's the worst.
What color are those?
why is it white?
It's white. Now, the natural question is, yeah, why is it white? I would say this is one of the natural world wonders.
Ragnarok was filmed.
Yeah, Ragnarok probably formed here. There's a large expanse of coastline that has super steep, super tall, white cliffs. Now, I don't know about you guys, but it's pretty rare that I see a mountain or a cliff that's completely white. That's a unique thing. That's why this is a world wonder. Why do you think it's white?
It keeps eroding over
Holy
and over.
calcium. Okay, it is 100% the calcium. Now, as we look at the Cliffs of Dover, what we're really seeing is a couple things. There's a type of rock that we're not in geology class, but limestone is a type of rock.
That's what I was thinking. I was like, wait, what's the whitest rock? Is it limestone? I think?
So I would say whitest is a hard question because I think you're probably going to find some marbles that are...
True, but like,
It's
like all
limestone
the
is
rock
white
I
for
think.
sure, yeah. It's white and kind of chalky almost, depending. Now, limestone contains calcium, as Donovan said. Whoa, that was weird. I just called you Donovan. That's weird. I know, that's never happened. Davian, I'm sorry. As Davian said, limestone contains calcium. Now, it's not pure calcium in its elemental form. Limestone, all right, back at it, guys, is a rock which has, or which contains, rather, calcium carbonate. Now, that is almost the same stuff as in that tablet that we dissolved and watched react in that water. Calcium carbonate is different because that's calcium bicarbonate. Okay, calcium carbonate. Turns out calcium carbonate reacts with a certain type of acid called carbonic acid. We're not going to go crazy into the details here, but it's nice to know. Is there CO2 in our air? There is, absolutely there is. We breathe it out, we breathe it in, like all those things happen. Does sometimes on our planet it rain? I think so. So let's just logic together here. We have a bunch of CO2 in our air and the rain falls. Where's the rain fall through? It falls through to the ground eventually, but it goes through the air first, right? As rain falls through the air, is it possible that it has to pass through a bunch of CO2? Sometimes that CO2 sticks to the water molecules. Okay, that is carbonic acid. You can get a slightly acidic rain just by it falling through big amounts. You might call it acid rain. Yep, you've talked about it. Turns out carbonic acid or acid rain. We have 10 minutes. If you're going to pop, you can, but I'll leave it up to you. Okay, acid rain, it turns out, reacts, I'll get you, Edison. Acid rain reacts to produce our Cliffs of Dover. It is 100% millions of years of carbonic acid, or acid rain, and CO2 in our atmosphere reacting with that limestone cliff to produce something like the Cliffs of Dover. Okay, that one is neat, and I think it's super cool. It's a world wonder. I would love to see them in real life. Eventually, I think we'll get there. Addison.
When you said the acid rain, that reminded me, because we learned about that last year, and she said something about, like, a lot of it, like a lake of, like, the acid rain, and then you could throw a body in it, and it would just completely, like, decay.
That's metal. I don't know what, like, that's super cool and dark, but like metal, like,
Oh.
yeah.
I was confused.
Oh, no, I can see, because we're talking about chemistry. I see what you, yeah. All right, now, the other place that I think that's kind of cool with limestone, the Cliffs of Dover are super cool. You guys ever gone into a cave?
Yes.
Like a big cave?
No, not you.
Okay, so where I'm from is what's known as Wind Cave, and I think, just for the record, do you guys know what the actual verb of what you call cave exploration is? Like if somebody sails on a boat, they call it sailing, right? If somebody participates, and this is weird, I don't know why this is in my head, but if somebody were to ride on a horse with a joust out in front of them, and they're competing, they're jousting, right? Okay, if you're going through a cave, you may hear somebody refer to it as caving. That is the informal word. You guys, spelunking.
Oh, yeah. I've heard that. I don't know why I've heard that.
Spelunking is like going through caves. Now, first little thought, and I just want to make sure everybody's clear. Spelunking is super dangerous. Really, really dangerous. Terrible thing to do. You don't go into a cave without like the proper equipment. Don't go cave exploring on your own. You can find a million YouTube videos of like the most uncomfortable stories about that. Now, yeah, oh, for sure. Now, something, however, that does happen in a cave, those of you that have been in a big cave, cold or warm? Cold, wet or dry?
Damn.
They're normally wet. Why?
What is it in there? Condensation.
So, part of it's condensation, but part of it's water. We're going to think about caves in general. Now, we are not in geology course. We're not going to go into like the whole formation of caves and everything, but there is one nice other chemical weathering or chemical event that happens all over. We're going to draw a cave. So check it out. Here is the surface of our planet. Boop, boop, boop. There I am. Cool. All right. Now, is it possible that there's a hole here in the ground, right? Now, that hole might just possibly open into a big, elaborate cave system. You guys cool with that? Like there's caves, and usually they like offshoot, and they can be huge or small. Okay. Now, this is not to scale. Are all caves just barely below the surface?
No.
No, most of them aren't, right? Now, some of them are, I guess, rather. But let's hypothetically say it poured rain above this cave. Okay, it could fill the cave, but maybe, I just didn't draw it, maybe this cave actually opens up into like a cave shaft, and you don't have to change your drawing, just so you know. You can if you want to, but it could fill the cave. I'm going to pretend it doesn't. Like, the water has an outlet, maybe eventually it leads out. Will the rain, if it falls, hit the ground?
Yeah.
And then it just sits there forever and never leaves?
No, it stinks.
It could stink. Where does that water go? Two options.
Down.
You can either go down to the ground, which does happen, so you're going to eventually wind up with a bunch of water that's kind of just scattered around here. You guys cool with that idea? That's groundwater, right? Okay. Gravity wants that water to go where? Down. Okay. The other option was evaporate, just so you guys know. Eventually, there's going to be so much water up here that it's going to start sinking down through the ground, right? It's dirt and rock and things like that. You could get sinkholes, but there's a cooler thing that happens. Okay. As that water filters through all this rock and dirt, is it possible that it picks up minerals along the way? So check it out. We have two different things. We have ground with water above. You're going to get two different types of structures possibly forming. You're going to get structures that form from the top like this. You're going to get long, pointy rocks from the ceiling. Okay.
Don't they become beams after like?
So let's get there. We're not in a geology class, but there are big things that come down from the top of caves. Okay. As we're looking at it, check it out. Because I've heard people say them. These right here are an effect or a result of some chemical weathering that's happening inside of your cave. These are not stalagmites. These right here are stalactites. Okay, now I'm going to be very intentional here. Stalac, S-T-A-L-A-C. Check it out. It's going to be annoying. Tite, T-I-T-E. It is not really capital. I do this for a reason. Stalactites are in contrast with a different thing that forms. Maybe the water is running too fast to slowly just form this stalactite as it works its way down. Instead, is it possible that the water actually drips all the way down and hits the floor? And in that situation, just maybe, that water drips and it starts forming these little pokey things, and instead of coming down from the ceiling, come up from the floor. Reasonable. Okay, we have stalactites with a capital T written out here. And then on the other side of that, we have stalagmites. So check it out. This is also going to be obnoxious. Stalag, S-T-A-L-A. Capital G is what I'm going to write this with. Stalagmites. Okay. There's a very intentional reason I know it's annoying. Capital T and a capital G on both of these. Stalactites form on which part of the cave? The top. T is for top.
Oh, T and G for ground.
Ground.
G is for ground.
Isn't it also called the dripstone?
That's in Minecraft. That's Minecraft.
That's my
I thought that.
I've never heard of that, huh? Okay, so looking at it, stalactites, I'm sorry, from the top, stalagmites from the ground up. Kennedy mentioned that if it just works out perfectly, you might be able to get them here. There's a scene from Futurama that I think we could use to just, it's a really nice scene. I'll find it, we'll watch it at start of class tomorrow. Okay, going through this. Chemical changes are occurring. We have water running through the rock, collecting minerals. Those minerals then collect and deposit, and we get this whole new structure getting formed. This is chemical weathering. Now, the last little thing that we're going to talk about, and I'll have a demo for us tomorrow that is going to be crazy. Last little piece. We are going to possibly finish, but we'll see. Final little piece of this section, because it's a big one. The law, and this is really important in chemistry, the law of conservation. Have we seen that already? Okay, conservation of energy says what? Can't what?
Can't destroy or create.
Can't create or destroy. And you're probably getting to the same ideas there, just so you know. With this time, we see the law of conservation show up again, but we're going to talk about the law of conservation of mass. Okay, for this, super easy to define. Instead of saying energy cannot be created nor destroyed, mass cannot be created nor destroyed. Okay, so here we go. We're going to write this out a little bit more formal. In a chemical reaction, the mass of the reactants which we haven't defined this word, but we'll make sure we see it. What do you think the reactants are?
Like the things that are reacting.
The things that are going to react, right? The mass of the reactants is always equal to what? If we have things that react, right? And do you agree that if you have things reacting, they're going to form some product? The product is like the end thing that's made. Everybody okay with that language? If you have reactants on one side, they produce something, right? We have to produce something new, a new substance of some sort in a chemical reaction. We have reactants on one side that react to form the products. So in a chemical reaction, the mass of the reactants is always equal to the mass of the products. Okay, we're going to write one more thing, and then we're not quite going to be able to have homework, which is kind of a bummer. Okay, here we go.
Wait, if you burn something that has mass, like,
Oh my question. That's such a good question. Check it out.
Make it up for you.
I'll tell you, you are going to want to say that you're destroying some mass. You are not. I'm going to have a quick little example here because let's think about this. I'm going to have wood, which is not super chemical at all. But if I want to react wood and oxygen, there's one main type of reaction that is. When you react something with oxygen, it burns typically. These on this side are our reactants. Okay. Now, here's the part that I want you to think about. If, and I guess we'll just, yeah, we got time. If I burn this, what results at the end?
Fire.
Okay, so you make fire. How would you, I can't write fire. I'm just gonna write energy.
Flammability.
So it is energy, that's flame, you're right. What else is made when you burn wood?
Oh, Josh.
Gas,
Carbon
holy
dioxide.
gases. Yeah, carbon dioxide, there's a bunch of gases. Anything else?
That one. Heat.
Ash. Heat, you're right, Kennedy, but that's the energy. Okay, so check it out. We have our reactants, wood and oxygen, that are reacting together to produce our products of gas, energy, and ash. And this right here, this arrow, tells me the direction that reaction goes. Can you unburn wood?
Yes.
I can't. If you can, show me. That'd be awesome. I'll see you cool cats and kittens tomorrow.